video we have discussed about padding. In the previous video to that we discussed about stride as well. By now we have completed discussing about convolution layer, ReLU layer, and also we have discussed about pooling layer as well. Now let's see the overall picture how it goes. So initially we might have some input shape, something like n cross n. On that n cross n input shape, we might have some kernels in case of convolutional layer, and the kernels might be of size k cross k, and there can be m such kernels. Due to that, the output shape will change in such a way that we'll be having m feature maps, and the feature map shape will also change. It will not be n cross n. After applying convolution operation based on stride and padding that we apply, it might change to something like n dash cross n dash cross m. I'm not exactly writing what is this n dash because we are going through several layers, so that's why it will be difficult for me to track for each and every input shape. So let's represent it like this: n dash cross m, and after that we'll be applying pooling. So if you guys remember, in pooling what will happen? In pooling, mainly the size reduction will happen. That's why instead of representing with larger square box, I have represented with a little smaller one, because in pooling the size reduction happens. In order to show that, that's why I did this. So but in pooling, the third dimension will not change, only these dimensions will change. That is, like here also it will remain m, the third dimension, but the input dimension will drastically change. It might go up to half, okay, or it can be even lesser also based on the window size that you are having. So let's say it is n double dash cross n double dash, okay. So this is the output shape of pooling, and on this we might again apply convolution, okay. So there, this convolution, ReLU, and pooling can be applied multiple number of times. So let's see, if we are applying it for second time, how it will be looking like. In some real world code example, we'll be discussing it in more detail. Here also we'll be having some convolutional layer. In convolution layer, you guys know, right? Here we'll be having some kernels, and kernels might be of size k dash cross k dash, and there can be m dash such kernels, okay. So here, let's say we are having m kernels, but here it can happen that we are having m dash kernels. Then in that case, my output shape will be n triple dash. So for now, let's say this is changing to n triple dash. And what will be the third dimension? The third dimension will always be dependent on the number of kernels in the convolutional layer. So here the number of kernels are m dash, so it will be m dash. So how this is working, all these details maybe in some other video we'll be discussing, but the change in output shape will be like this, okay. So the third dimension will change to m dash, whereas input dimensions will change according to the formula that we have already discussed, okay. And then we'll be applying this pooling, and in pooling obviously there will be reduction in size. It will be this n triple dash, right, and four dashes, think of it like that, m single dash only, because in pooling the third dimension will not change. So this is remained as this, and these will be changing because in pooling the size reduction happens. So this will get reduced to n4, okay. So this is about convolution and pooling, like that multiple times. Even further also you can apply again another convolution and another pooling. In the similar way, it changes the dimensions. And after applying the convolution, pooling, ReLU, and pooling for multiple number of times, what we can do, we can apply flatten at last after completing all the convolution, ReLU, and pooling operations. So what does flatten mean? Flatten means that we'll take individual values of the feature maps. Like how many individual values will be present across all these feature maps? It will be n4 cross n4 cross m dash. That is, if you take each and every value x1, x2, so on, it will be n4 cross n4 cross m dash. These many number of values we'll be getting. Let's say, let's take some values. Let's say it is 2 cross 2 cross 6. So let's say finally this is my output shape. Then here, after applying flatten, the number of inputs will be 2 cross 2 cross 6, that is 24. So x1, x2, so on, x24. So these many number of inputs we'll be getting, and these inputs will be fed to some ANN. Simply the structure that you're seeing over here is simply ANN, right? So instead of calling these as dense layers, we'll be calling them as fully connected layers. That is the only difference. These inputs will be fed to the first fully connected layer that we have, and similarly this x2 will be fed to the first fully connected layer, and this one will be fed to the first fully connected layer. Like that, all these will get connected. You guys all know all this, right? Because I hope you might have seen already ANN videos. So there I have clearly discussed how this is happening. Okay, so like this, all these fully connected layers will get connected, and there can be multiple such fully connected layers. And finally, we'll be having the output layer, and through the output layer, we'll be getting the predicted output. This is the overall picture of CNN. If you guys remember, what is convolution helpful for? Convolution is helpful for extracting out features. So if you think of each kernel is representing some feature, then here this convolution operation is completely extracting out m such feature informations, and it is showing them with the dimension of n dash cross n dash, but these dimensions are very large. Okay, so as these are large, what we are doing, we are applying pooling on this, which will reduce the size, and it will show the same information that this particular feature map is showing. Here there is size reduction, and same information is getting carry forwarded. So that is the help of this pooling. And similarly, on this feature map, again we'll be applying convolution and ReLU, which will extract out even complex features out of this particular feature map. And finally, once we feel that we did some enough reduction and we have extracted out all the important features out of it, then completely we can apply flatten, which is arranging them like this, arranging the individual values like this. And on that, we'll be simply applying the ANN, okay, ANN part. So instead of having hidden layers, we'll be having the fully connected layers. That is the only difference. You can also think of these as hidden layers. If you haven't seen ANN, then please go check out the videos. Then you might understand this portion completely. And now there are two questions. First question is like, what kind of task can we do with the help of CNN? Like, can we do classification tasks, or can we do regression tasks, or can we do both, or only one can we do? And the second question is, what are parameters in case of CNN? Okay, and similarly, what are hyperparameters in case of CNN? So before going on to the next video, please comment down your answers for these two questions. That is, what kind of tasks can we do with CNN with some examples? And similarly, what are parameters and what are hyperparameters according to you? Okay, we'll answer these two questions in the next coming videos. I hope everything is clear till this point in time. If you have any doubts, please comment down in the comment section. I'll try to help you out. Thank you everyone. Bye bye.